Okay, that's part 3 of the lecture series, in which we seek to understand what Python is at the most fundamental level. We break things down to intuitive components and strive to get an accurate, big picture of all kinds of programming languages and how Python fit in there. Alright, remember, we stopped at Python being an object-oriented programming language. Now let's discuss what that means. Well, object-oriented programming is one of the many programming paradigms. You see, there are such things as programming paradigms. When you have a problem, you write a program to solve the problem, and you can write the program in many ways, and those ways have names, paradigms. So the programming paradigm is a specific way or style of programming. Since programming itself is a very creative process, no wonder why there are different styles of doing this, just like there are different styles in art. Okay, let's take a look at some of the most popular programming paradigms. So, two major types of programming paradigms are imperative and declarative. So, simply speaking, imperative is about how to do something, and declarative is about what to do. Imperative paradigm splits up into procedural and object-oriented programming paradigms, and declarative divides into functional and logical programming paradigms. So, when we write programs in an imperative way, we precisely describe to the computer how to solve a problem. So we write step-by-step instructions that are basically ordered commands, or imperatives if you will, that computer should follow to get the desired result. And when we write programs in a declarative way, we just tell the computer what we want to get as a result. We just specify what exactly we need, and that's it. So let's explore the idea of imperative versus declarative by comparing it to something that you're more familiar with. So let's consider a really common problem. You are extremely hungry, and you want to eat pizza. So let's say you're at home, and you don't want to go out. So you have two basic ways to approach the problem. You could cook pizza yourself, or you could order it. One way is imperative, another one is declarative. I encourage you to pause the video and think which is which, if of course that's not obvious to you. Alright, so hopefully you got it and let's check it out. So if you cook it yourself, you are definitely gonna use some recipe. So you will follow step-by-step instructions, which are basically ordered imperatives, like do this and then do that to cook the result, or in programming lingo, to get the output, which in our case is pizza. So it's an imperative approach for solving this problem. If you decide to order pizza, you just go to the website and specify the kind of pizza you want and where to deliver it. And that's it. You don't care about the cooking process, you just send a request with all the details and you get your pizza, no instructions how to make it. So it's a declarative approach for solving this problem, since you don't care about what step-by-step instructions are needed for the process of cooking pizza, you just specify what exactly you need and you get it. So let's recap. Imperative paradigm is like when you cook following a recipe, and declarative paradigm is like when you order something. By the way, if you are hungry now, I'm sorry for showing you this picture of delicious pizza, because I just wanted you to remember the analogy better, so you can recall it later on. Thus, if now you want to eat pizza, go ahead and grab one. Just make sure you finish a bunch of lectures more, so you can reward yourself, and you can get pizza whichever way you want. Personally, I prefer both imperative and declarative ways. No surprise why I'm fond of Python, huh? Alright, now that we know two general types of programming paradigms, imperative and declarative, let's go ahead and break down each individual programming paradigm, namely procedural, object-oriented, functional, and logical. But before that, I want you to keep in mind that this stuff can sound quite theoretical and very abstract at this point, but once you get practical experience with coding, it becomes very intuitive. So let's briefly discuss procedural paradigm. Well, first, we already know that the procedural paradigm is a subtype of an imperative programming paradigm. Procedural programming is sometimes called imperative programming and vice versa. It is based on, you've guessed it, it is based on procedures, also known as routines, subroutines, or functions. Usage of these terms depends on the programming language you use. So, when solving a complex problem using the procedural paradigm, we break it into smaller pieces called procedures, or routines, subroutines, functions that are reusable. So we can call these pieces of the program whenever we need them. And this approach of starting with a big and complex task and ending up with small and simple pieces is called a top-down approach, and it's an important characteristic of procedural programming. In procedural programming, the programs consist of data and operations, meaning procedures, functions that operate on that data. So these two, the data and the operations, are separated. I want to emphasize it one more time. In procedural programming, data and operations are two different things. Alright, let's talk about object-oriented programming. So just as procedural, the object-oriented paradigm is a subtype of an imperative paradigm. It's based on, that's right, it's based on objects. Remember, in procedural programming, data and operations are separated, but here, in object-oriented programming, these two are considered to be one thing, a single entity called an object. So the object is a mixture of data and operations. Simply speaking, in object-oriented programming, or just OOP, the program is divided into small chunks, called objects, which are instances of classes. So for now, we're gonna stop here. And at the next lecture, we're gonna make this seemingly complicated paradigm of OOP very intuitive, and discuss other paradigms, and why we need them in the first place. May curiosity be with you.